Okay, so here we have the limit of a polynomial. Now, for polynomials, we showed that direct substitution works for these limits. Here we want to take the limit as x approaches -2. So in other words, wherever we see an x, we're going to plug in -2. So sometimes it works. Let's see. Here we plug in -2, right? And just evaluate. So we have 5 times 4 plus 2 plus 3, or 20 plus 5 comes out to 25. All right, so for polynomials, when you're taking the limit, just do the direct substitution. Plug in the value to which you're tending, and you'll get the answer. Now let's try another one. Okay, so you can see here we have another one. This one's a rational expression. It's got a square root in it. But here, we're taking the limit as x approaches 4. So here we'll do the direct substitution. We'll just substitute 4 in and see what happens. So we have the square root of 4 minus 5 over 4 minus 25. Right? Just do the direct substitution here and then simplify. So we get, what, 2 minus 5 over 4 minus 25 is negative 21. Okay, or negative 3 over negative 21, which is, I'm going to cancel a 3, or negative 3, and I'll have 1/7. So you can see here we got the limit here just simply by doing direct substitution. Now this doesn't always work. Sometimes they're going to, or a lot of times in the textbook problems, they're going to tend towards either restrictions or holes or something like that. And so instead of tending towards 4, what we'll do next is tend towards 25. All right, same problem. X is tending towards 25 this time. Now when we do the direct substitution, you can see we're going to run into a problem. So the direct substitution here, we would get square root of 25 minus 5 over 25 minus 25, right? Which is 5 minus 5 in the numerator and 0 in the denominator. We get 0 over 0. Okay, now 0 over 0 is indeterminate. That really doesn't tell us anything. So this limit can't be solved using direct substitution. Now what we do know is that algebra, simple algebra simplification, doesn't affect the limit. So what we're going to do is simplify this a little bit, or change its form, and then see if the direct substitution works. Okay, and the technique that I'm going to choose is to multiply by the conjugate here. So I'm going to multiply numerator by square root of x plus 5, and the denominator by square root of x plus 5 as well. So whatever you multiply the numerator by, you have to do the same thing to the denominator. All right? So I'm not actually taking the limit yet, so I need the notation. X tends to 25. Just going to do the algebra. So when I FOIL out the numerator here, I'll be left with x minus 25, right? Square root of x times x is x. The middle terms will cancel, and then negative 5 times 5 is minus 25. Okay, and I'm going to leave the bottom factored. So x minus 25 times square root of x plus 5. Because I can see now in this form, I have a common factor here that can then cancel. All right, so dividing out x minus 25, we're left with the limit as x approaches 25 of 1 over square root of x plus 5. All right? Now the factor that produced the indeterminate form is right here, right? When I plug in 25, I get 0 over 0. So that's gone now. So now at this point, I can apply direct substitution, right? And simply plug in the value to which I'm tending. All right, so in this case, x is 25. So we have 1 over the square root, substituting in 25, plus 5. We get 1 over 5 plus 5, which is 1/10. And that's going to be our limit. Okay, so in this particular case, direct substitution gave us indeterminate form, so we had to do something different. We multiplied by the conjugate, and simplified a little bit into the point, we got it to a point where direct substitution did work. Okay, so always try your direct substitution and algebra to simplify things, and these limits will go a little bit smoother for you, hopefully. Good luck.